everyone. So I'm really annoyed right now because I've already recorded this video once, but apparently I took too long. You can't upload anything that's longer than 15 minutes. The last video is 18. I've got to talk faster and show you a little less. All right, so let's get started. This is exercise 8B and we're looking at reducing balance loans using recurrence relationships. So when you borrow money from the bank, the usual thing is you make regular repayments. So if I borrow $1 million to buy a house, every month I pay a certain amount of money back, and it might take me 35 years to pay that money all back to the bank, and then I would own my house. All right, so as I said, they're called reducing balance loans because every time you make a payment, you reduce the balance a bit. They involve compound interest, so that's our geometric growth part. And the most common examples are your mortgages and your personal loans. All right, so with the recurrence relationship, we use the very similar format to the other ones. We're going to have our VO for our principal, so the amount that's borrowed from the bank. VM plus 1 will equal the rate multiplied by the principal or the balance of the loan, and then we'll take away any repayments that the person makes. Okay, so our first example, which you'll notice is not on the board because I've already rubbed it off, but I'll go through it. You've got the notes. So Penny borrows $1,000 and the bank is charging her an interest rate of 15% per annum, and that's compounding monthly. She's going to repay the loan by making 4 monthly repayments of $257.85. So if you think about our recurrence relationship, we're going to have VO is the principal, so the principal is $1,000. VM plus 1. Now, it's 15% for the year, but it's compounding monthly. So we have to do 15 divided by 12, which gives us 1.25%. Now remember, we don't want the number as a percentage, we want it as a decimal. So we have to divide that by 100 to get 0.0125. Now remember, we have to add the 1 on because this is big R, so 1 plus 0.0125 will give us our compounding rate of 1.0125. And we know D, that's going to be the repayments that she makes, and that's going to be $257.85. All right, so question number 1. What is going to be the balance of her loan after 2 repayments? So we start with our VO, and that's $1,000. Our V1, that's going to be $1,000 multiplied by the rate, which is 1.0125. Then we take away the payment, and that gives us a new balance of $754.65. V2, we take that $754, that becomes the new balance. So $754.65 multiplied by the rate of 1.0125. Then we take the payments off, and that gives us a new balance of $506.23. Now, this type of processing can be summarized in an amortization table, but it's really important that you understand the order. So we're going to have a closer look at what we've just talked about with Penny's loan. Okay, so Penny's loan started off with a principal of $1,000. Now, the interest was added onto that, which was $12.50. So at that interest rate, $12.50 was added in the first month. Then Sally makes the payment. So the bank adds the interest on first before the payment's made. You must remember this order because questions will specifically be asked, what is the value at this particular point? And you have to know the sequencing. So we started with the principal, the interest was added. When the payment's made, paid, two things happen with the payment. First, the interest gets taken away. So the first part of the payment is used to deduct the interest of $12.50 in this case. The rest of the payment, which would be $245.35, goes to reducing the principal. That's why it's called a reducing balance loan. And that gives us a new balance of $754.65. Remember, the order is very important. You must remember this. We go to the second month. We bring this balance down. We work out the new amount of interest. So up here, the interest was $12.50 because we had $1,000. The same interest rate is applied to the $754, and that gives us interest of $9.43. When the payment's made, the $9.43 is taken away, and the $248.42 reduces the balance. So we get a new balance of $506.23. Okay, so that is the process. And we summarize that in an amortization table. You will always, I will bet money on this, get an exam question or a SAC question where you have to complete an amortization table, either from scratch or there'll be missing numbers in the table and you will have to fill it out. Bet money on it. And I can probably do that because I wrote the SAC and I know. Okay, so here's your amortization table and I'll show you how it gets filled out. The first line is really simple. We don't have a payment number, we haven't gotten a payment amount, so the first line is all zeros, except the last balance of loan, you put the principal amount in there. First line every time. Okay. Payment number 1. It's going to be $257.85. The first thing that's going to get paid is the interest of $12.50. So if you think about this sum, this amount, the payment amount minus the interest equals how much the principal is going to be reduced. So that, take away that, gives us $245.35. So the new balance is going to be this number here minus this number, which will equal $754.65. Okay? That's how we fill it out. That's the maths that's involved. Let's look at the next line. We're going to have payment number 2. Payment number 2 is also for $257.85. Remember, the interest this time is $9.43. So that minus that equals $248.42. To find out what goes in this spot, we take this value, we subtract that, and that gives us our $506.23. So we've got a subtraction here, which equals this value, and then we do a subtraction from here, the balance, minus the principal reduction will give us the new balance, and so on. Until we get to the last row of the amortization table. Okay, this is where things get a little different. So you've got this balance here, that's what's still owing. You don't do anything with the payment just yet. The first thing you do is you work out the interest, only because this is the last row, and you add them together. That is what the final payment will be. Sometimes it has to be a little bit more. In this case, it's 4 cents more. Sometimes it's going to be a little bit less. That's why you have to do this part first, work out the interest and add them together to work out this value. What is the final payment going to be? and then that's going to give you your 0 here. When you add this up, it should add to 1,000, which was the principal, and when you add this up, it'll tell you how much interest Sally had to pay on her loan, if that's the question you get asked. Okay? That is how an amortization table works. And as I said, there will always be a question on amortization tables, so you need to know the process for filling them out, and you need to know the order that things happen in. Alright, that's all I've got for you, and I managed to do it in 8 minutes faster than I did it the first time. Okay guys, I'll see you on WebEx.